All right, so this example, I mean, the instructions are to find all relative maximums and minimums. Relative means the same thing as local. And also find the absolute maximums or minimums. Absolute is the same thing as global. So, and we're doing it only on the interval from -4 to 2. State their values and location. So state the actual maximums or minimums, and the location just meaning the x value where it occurs. So from the last video, we know that we can have a possible relative maximum or minimum when the derivative equals 0. We can see what kind they are by doing a sign chart. We can see if it's a relative max, if the derivative goes from positive to negative, or a relative minimum if the derivative goes from negative to positive. So right now, the first thing I'm going to do is find critical points, because those give me possible spots where I could have a relative maximum or a relative minimum. So let's do that right now. So I take the derivative, and then I set it equal to 0, and I'll solve 24x squared plus 162x minus 42. I'll solve. That's just factoring. If you need help with that, then let me know. You can verify it on your own. But we get x equals 1/4 and x equals -7. So I could have a relative maximum or minimum here, and I could have a relative maximum or minimum there. I don't know whether they are relative maximums or minimums until I do a sign chart, and then I'd be able to tell. So I guess I'll do that right now. Technically, we don't need that for the absolute part, but for relative maximums and minimums, we definitely need a sign chart. So I'm going to do -7 and 1/4. So those are my critical points, and I'm plugging into the derivative because I want to know when the sign changes, because when it changes, I mean, that tells me whether I have a max or min. So -7, I'll do -8, I'll do 0, I'll do 1. And I'm plugging it into this function. So you can check my work, but I already did this. I'm just going to try and speed it up. It would be positive, negative, positive. So when x is -7, I go from positive to negative. That's a relative max, right? And then, okay, so from negative to positive, that's a relative minimum. So relative minimum. However, we don't need that -7 because the interval that we're focusing on is just from -4 to 2. So we don't really need that part. But if there were no restrictions, yes, there's a relative maximum at x equals -7. I don't know what the relative maximum is. I just know where it is. Well, how do I find what it is? I simply find the y value for this x value. And that's just by plugging it into the original. So we'll check that. But here are my candidates. I have a relative minimum at 1/4. I don't know what the relative minimum is. And then I have to check my endpoints as well. I have to check to see if these are really low or high. Because I could, let me just draw some pictures. This is aside from this problem. I'm taking an aside. So I don't really know what the graph looks like, but I'm going to make something up. I have restrictions from -4 all the way to 2. So if my graph looked something like this, I just made that up, we would restrict it. We would get rid of this part and stop there, and we get rid of this part, and we'd stop right there. So that may be what my graph would look like. Again, I just made that up. So here's the thing. It could look like that. It could look like -4, -2. It could look like this if that's the lowest point. Maybe something like that. And then this is the highest point. Or it could look like, I'm just drawing different scenarios just to talk about it because I want to make sure everybody understands oh, that's a +2, sorry. It could look like, I don't know, like this. Right? Could look like, I guess it could look the other way. You don't have to write this down. You don't have to write any of this down. This is just an explanation. It could look like this, right? Okay, so in this scenario, we have two relative maximums or relative extrema. Here, this is a relative maximum. Here's a relative minimum. And the endpoints, like there's no possible way that that point or that point could be the absolute max or min, because there's a higher value and a lower value than both of these endpoints. So that in that case, we would just have to see, which one's higher, which one's lower. And from the graph, we can see, but we can't see that when we don't have a graph like what we have over here. If the graph looks like this, then the endpoint is an absolute minimum, and this would be just a relative minimum. This would be a relative maximum, and the endpoint would be a an absolute maximum. So that's another scenario. In this scenario, this would be two things: relative minimum and absolute minimum, because it's the lowest y value. This would actually be nothing, because the highest, the absolute maximum, would be over here. On this one, we would have an absolute maximum here and a relative maximum. It's both. Remember, at endpoints, you cannot have relative maximum or minimum. Here would be the absolute minimum. This would be nothing. So really, what we need to do is test our relative extrema and the endpoints to see which one of these cases we get. So how do I test them? Well, I plug them into my original function because I want to know the y values. Remember, maximum values, we're talking about the y values. So I'll check my relative extrema and I'll check my endpoints. And we'll interpret that after. So I'll check f of, well, we don't have to check -7 because that's not in our interval. So I'm going to check 1/4, f of 1/4. And I already plugged it in. I already have the answer there. So that one comes out to be -13.313 if you round to 3 decimal places. I think. Maybe not. I don't know. And then I need to check my endpoints. So f of -4, what does that equal? Well, I also already did that. That's 944. And then f of my other endpoint was 2. So I'll check that. And that has a y value of 296. So remember, relative extrema, meaning maximum or minimum, even absolute extrema, maximum or minimum, they are just the lowest value or the highest value, right? So if we're thinking about absolute maximum, well, that would be 944. So there's an absolute maximum at x equals -4, that's the location, with a value of 944. So that's part of our answer. We also have, well, what's the absolute minimum? The smallest one we have is this. So the absolute minimum, abs min, is -13.313 at x equals 1/4. So we have that. F of 2 is nothing. That ended up being like that spot. That's kind of like the f of 2. It was neither the max or the min. We had the relative. Remember, this was a relative minimum. Oh, it is almost. It's like the reverse scenario of this. It's actually like where it's high and then low. Right? This is the 1/4. It's the relative minimum, which also is the absolute minimum. So we would say that this is a relative or local minimum as well. So then now we have everything, I think. Yeah, it turns out to be something like that, where at 1/4 we have a relative minimum and an absolute minimum. At x equals -4, we have an absolute maximum. That's that. And at x equals 2, it's neither a minimum nor a maximum, so it's nothing. I don't know if that makes sense or not, but we'll be talking about it more on Thursday, so goodbye!